Welcome to this episode of Daily Overdose of Papers. Today we will be talking about the UNIX Time-Sharing System by Dennis M. Ritchie and Ken Thompson, published in Communications of the ACM in July 1974. UNIX is considered a pioneering operating system originating in the late 60s. Our focus today is on the more modern version developed for the PDP 11, 40, and 45 computers, which brought significant improvements over its predecessors. UNIX provided a variety of advanced features, such as a hierarchical file system, device and inter-process communication compatibility, asynchronous processes, a user-based command language, and over 100 subsystems, including programming languages. UNIX's main achievements: a powerful and interactive operating system that's not costly in terms of human effort or equipment, demonstrating simplicity, elegance, and ease of use. Now, let's dive into the intricacies of UNIX, starting with its hardware and software environment, and later, its file system and processes. The PDP 1145, the machine UNIX was implemented on, is a 16-bit word with a sizable core memory for its time. Interestingly, UNIX itself occupied a mere 42 KB of space, demonstrating early efficiency in design. A diverse range of peripheral devices was supported, from paper tape readers to high-speed communications interfaces, demonstrating UNIX's early recognition of the importance of I/O device compatibility. A critical transition for UNIX was rewriting the operating system in the C programming language, which not only simplified the system, but also brought functional improvements like multiprogramming and shared reentrant code. The UNIX file system is key, providing a structure with ordinary disk files, directories, and special files that interact with I/O devices. This design allowed for a clean and user-friendly way to manage files and devices. Directories were a game-changer, mapping file names to the files themselves, which allowed for a structured way to access and organize data within the system. Special files bridged the gap between file and device I/O, streamlining access to I/O devices by treating them as files, a concept that was quite innovative at the time. The protection mechanism in UNIX was simple yet effective, using user ID and permission bits to control access, along with a set user ID feature for privileged programs. The concepts of images and processes are central to UNIX, with images representing the execution environment and processes being the execution of those images. UNIX introduced the idea of process forking, where a process splits into two, and inter-process communication using pipes. These features facilitated multitasking and complex task coordination. The system also included mechanisms for process synchronization and termination, ensuring that processes could be managed effectively and resources could be freed when no longer needed. The shell, UNIX's command line interpreter, played a significant role in the system's usability, allowing users to execute programs and manage tasks with simple commands. With features like I/O redirection, background processes, and filters, the shell made it possible to perform complex operations in a straightforward manner, promoting user efficiency. The shell also allowed for multitasking and the execution of commands in sequence or in the background, demonstrating early capabilities for concurrent operations within the operating system. Finally, the shell's recursive nature and the ability to interpret command files gave users the power to automate tasks and customize their interaction with the system. Reflecting on UNIX, it's evident that its success stemmed from the thoughtful exploitation of ideas rather than groundbreaking inventions, with a focus on interactive use, space efficiency, and the system's ability to evolve over time. Thank you for watching. If you liked this video, please like and subscribe. If you have any questions or comments, please leave them in the comments below. See you next time.